Hello, everybody. Welcome to SysGuide's YouTube channel. In this video, I'll show you how to install Fedora 38 with full disk encryption, snapshot, and rollback support. By the end of this video, you'll have your disk fully encrypted with LUKS, ensuring that your data is secure when you're offline. Furthermore, with snapshot and rollback support also enabled, you can very easily undo your changes and restore the operating system to its original state if you make a mistake or completely break it. So please follow through until the end so that you don't miss any important steps. I also have a text version of this video where I go over the steps in greater detail. So please take a look at the website as well. I have included a link to the website in the description. So let's get started. Boot your system using the Fedora 38 Live installer in UEFI mode. And when you get to the Welcome to Fedora screen, do not select the install option. Instead, select Live Desktop Environment. So open the Genome terminal. I'll increase the font size to make the commands more visible. Switch to super user. Locate the disk on which you want to install Fedora. For me, it is dev/vda. For you, it might be different. I'm using a 100 GB disk. You now need to create two partitions out of this disk, one for the EFI partition and the other for the Linux partition on which Fedora will be installed. First, create an EFI partition with a size of 512 megabytes, SG disk N1 : plus 512M T1 : EF 00 C : BFI /dev/BDA, and N is create new partition. One is partition number 1. The first colon indicates the start. In this case, it's empty, meaning from the start sector. And after second colon, it is the end sector. Here it is mentioned in the megabyte size, 512 megabytes. T is the partition type, partition 1. EF00 is the code for EFI system partition. C is change name. I'll name the first partition as EFI, but you can choose any name. Next, create a partition for Linux file system. SGDisk N2, partition 2 : which means use all of the disk's remaining space. T2 : 8300, which is a code for Linux file system. C : Fedora 38. I will set the partition name as Fedora 38, but you can choose any name and your device /dev/BDA. List the partitions you just created to ensure that everything is in order. Format the dev/VDA1 partition with the FAT32 file system. I'll also name the volume EFI, but you may name it whatever you want. Now I need to initialize the dev/vda2 partition as a LUKS device and set the initial passphrase. So type the command, crypt setup, LUKS format, type LUKS2, label. I'll set the label to Fedora_LUKS. You can set the label to your liking. PBKDF. PBKDF2. PBKDF, force iterations to 500,000. /dev/VDA2. Grub currently only supports PBKDF2 algorithm. For PBKDF2, the minimum iteration count is 1,000. The more powerful your CPU, the higher the iteration count, and the higher the iteration count, the longer it takes to unlock the LUKS in Grub. So I have set the iteration count to 500,000. Lowering the iterations count reduces the security. To get around it, use a stronger passphrase with higher entropy. Now open the LUKS device /dev/VDA2 and map it to the temporary name TMP LUKS. I'll map the LUKS device with the proper UID later. When prompted, enter the LUKS passphrase you provided earlier. Now format the map device with the Btrfs file system. I'll name the volume as Fedora, but you may name it whatever you want. And this is how your setup should look. The UUIDs will be unique to your system. Okay, this completes the first part of the tutorial, creating partitions and file systems. In the next part, I'll create the necessary directories and subvolumes so that we can install Fedora on that setup. In this section, I'm going to create the directories and subvolumes needed for installing Fedora. I've explained why I created each subvolume in the companion text version of this tutorial on my website, sysguides.com. Please visit the webpage for more details. I've included a link to the webpage in the description. I'll mount the LUKS encrypted Btrfs volume as the main volume rather than the subvolume. After Fedora installation and other configurations are complete, I will take a writable snapshot of the main volume and set this snapshot as the default subvolume for the system root. This significantly simplifies snapshot management and rollback. Let's start by mounting the system root to /mnt directory. Mount VO compress equals ZSTD:1 /dev/mapper/TMP LUKS. /mnt. ZSTD is a high-performance lossless data compression algorithm with compression level set to 1. The compression level can be set to any value between 1 and 15. A higher level indicates a higher compression ratio. However, compression level 1 is recommended and is the default for Fedora. We store default SE Linux security contexts. create a directory to mount the EFI partition. That is /dev/VDA1. Create a directory libvirt under var lib as well. When you install KVM virtualization, all of your virtual machine files and disk images are saved here. Now, mount the EFI partition to /mnt/boot/EFI. Now I'll create the required subvolumes in order to install Fedora. So when the Fedora installation is finished, I will create the remaining subvolumes. Subvolumes, unlike standard partitions or LVM logical volumes, don't have a size. Instead, they behave like directories with shared space. However, the resemblance of subvolumes to directories ends here. Each subvolume, like a file system, has its own file tree, has its own POSIX namespace, and has its own pool of inodes. This means that hard links cannot be created between the subvolumes. From this point of view, a subvolume begins to look more like a separate file system. Subvolumes are not block devices either. The subvolumes I'll be creating on the system root are created to avoid being included in the rollback regime, because some of these directories contain temporary files and caches. Others contain data that you do not want to lose. If the system root is rolled back, and some should be in read-write mode when booting into a read-only snapshot. Create a subvolume home. This subvolume contains user data. It is created to keep user data separate and also to avoid loss of user data on system root rollbacks. Create subvolume OPT. This subvolume contains applications installed by a third party, such as Google Chrome. It is created to be excluded from the rollback regime so that these applications are not uninstalled during rollbacks. Next, I will create 3 subvolume cache, crash, and TMP under var directory. These contain temporary files and caches, so they are created to be excluded from snapshots. Create a subvolume log. This subvolume contains log files. It is created to avoid the loss of log data during rollbacks. Create a subvolume spool. This contains data that is awaiting some kind of later processing, such as mail queues, printing, printer spool, and so on. Now create a subvolume www. This is where the web files for Fedora web server are stored. Next, create a subvolume called images. This is the default location for libvirt managed virtual machine images. Check the permission of /mnt/var/temp directory. It should be 1777. The initial set of subvolumes have now been created. List the subvolumes, and this is how it should appear. I'll create the remaining subvolumes when I install the desktop environment. This section is now complete. In the following section, I will install Fedora Minimal in the /mnt directory using the dnf install root and chroot environment. All right. Now that I've created all of the necessary directories and subvolumes, it's time to install Fedora. I'll install Fedora minimal in the /mnt directory using the dnf install root and chroot environment. So enter this command dnf -- release war equals 38, which is Fedora's current version, install root equals /mnt. This is the directory into which Fedora will be installed. Install base system. This base system package must be installed first because it creates the basic components of a Fedora system. It creates all of the basic directory structures required for you to easily bind the directories such as sys, dev, and proc into /mnt. So go to the web page, copy from for to done, paste it into the terminal, and press enter. Now that the directories have been bind mounted, install Fedora minimal in the /mnt directory. Go to the web page again, copy the dnf command, and paste it into your terminal. I've included Fedora minimal package groups, kernel language packages, grub packages, and some other relevant packages. You can add any additional packages here if you wish, or you can also install later. Fedora minimal installation is now complete. Remove the symbolic link resolve.conf from /mnt/etc directory and create a new resolve.conf file by copying it from the host to the /mnt/etc directory. This will allow you to connect to the internet when you exit the ch root and boot to Fedora minimal. Set the time zone, locale, key map, hostname, and machine ID. I will set the time zone to India and the keyboard language to India English. Change the setting according to your location. I've also set the host name to Fedora, but you can name it whatever you want. And if you want to determine your time zone, check the /user/share/zone info directory. To determine your locale, run locale ctl list locales command. To determine your key map, run locale ctl list key maps command. And finally, chroot into the /mnt directory. You are now in chroot environment. Enable the fastest mirrors to speed up package downloads. Go to the web page, copy the command from cat to EOF, paste it into your terminal, and hit enter. Clear all previous caches and update the local DNF metadata cache. before creating a new user account, you first need to reinstall the pulkit package so that the pulkit's scripts are properly regenerated. Now proceed to create a user account. I will create a user with root privileges. Change the username and comment to something more specific to you. Set the user password. Ensure that a user account has been created with the correct information. Now that you've created a user account, the next step is to create and populate the fstab with appropriate mounts. Set the Btrfs subvolume mount options to options variable. Get the UUID of your EFI partition and set it to EFI underscore UUID variable. Get the UUID of your Btrfs system root and set it to root underscore UUID variable. Get all of your subvolumes and set to variable subvolumes. Copy the printf command, paste it into your terminal, and press Enter key. Check the fstab file to make sure the system root is added. Next, print the EFI partition in fstab file. Copy the other printf command, paste it into your terminal, and press Enter key. You must now add the entries for the remaining subvolumes. Copy from 4 to Done, paste it into the terminal, and hit Enter. Examine your fstab file. This is what it should look like. The UUID and username will be unique to your system. Mount all of the subvolumes listed in the fstab file. Check your subvolumes. It should look something like this. And your setup should now look something like this. Now that you've created a user account and finished creating the fstab file, it's time to enable crypto disk and snapshot booting to allow encrypted boot and snapshots to boot directly from Grub. So first, get your LUKS partitions UUID and store it in the variable LUKS_def_UUID. This UUID must be entered into several files. The UUID can be obtained by running the command crypt setup LUKS UUID/dev/VDA2 ensure that the variable contains this UUID value. You must now create the grub file that will control the operation of the grub2 mkconfig command. Go back to the web page and copy from cat to EOF. Then paste it into your terminal and press the enter key. Make sure the file contains the correct UID of your LUKS partition. In my case, it is the UUID of /dev/VDA2. Make sure the grub enable crypto disk equals Y option is enabled. When you enable this option, it will look for encrypted disks and generate the extra commands needed to access them during boot. Also ensure that the option SUSE etrfs snapshot booting equals true is enabled. When this option is enabled, you can boot from snapshots directly from Grub. This is also useful when rolling back a snapshot. You must also make changes to the grub.cfg config file in the EFI partition. So open the file and insert the line set Btrfs relative path equals yes. And crypto mount -u and the UUID of your LUKS partition. Unlike file system UID, the UUID for encrypted device must be specified without dash separators. So remove the dashes from UUID and save the file. Update the grub.cfg file. Run the grubby command to ensure that the kernel arguments line in the grub.bls file contains the correct UUID as well. Now you need to add the encrypted block device to the /etc/crypt tab file so that it is enabled when the system boots. So add LUKS, the UUID, and UUID equals the same UUID, none and discard. Save the file and exit. Enable this network manager service so that you can connect to the internet after you reboot. Also enable the audit D daemon. The audit D, the Linux audit daemon, is the user space component to the Linux auditing system. Now run the fix files on boot command. This command will correct the SE Linux security context database on file systems on the next boot. Now exit the ch root environment. Unmount all the mounts recursively and reboot your computer. The system will reboot twice. The first time it boots, it relabels SE Linux contexts, and the second time it logs into the operating system. Enter your LUKS passphrase. When entering your passphrase, there will be no asterisk cursor indication. So you should assume you entered your passphrase correctly. Simply type in your LUKS passphrase and press the Enter key. Depending on your computer CPU, it may take up to 15 seconds for the Grub to display the menu. So please be patient. You will also be prompted for the passphrase twice. The first time is before loading Grub, and the second time is before mounting the root file system. In the next section, I will show you how to bypass a second passphrase prompt. SE Linux contexts are now being corrected. Now the system will reboot again, this time to log in to the operating system. Enter your first LUKS passphrase. Enter your second LUKS passphrase. Like I said, I'm going to show you how to bypass this passphrase prompt in the next section. Enter your username and password. And you are now logged into Fedora Minimal. The Fedora Minimal installation is now complete. You can now remove the Fedora Live installation media. From now on, the configuration will be done on Fedora 38 Minimal itself. In this section, I will show you how to bypass the second LUKS passphrase prompt when booting the system. I will show you two methods for automatically decrypting your disk without requiring you to enter the second passphrase using a key file or using TPM2. Also note that I have removed the Fedora installation media and am now working directly on the Fedora Minimal setup itself. Since I'm working on the console, let me first increase the font size. Install the package Terminus fonts console. Change the font. The command is set font TER-122N. Here, 1 is ISO 1, some sort of standard, I suppose. 22 is the font size, and N is the normal font. If you want a bold font, replace N with B. And the fonts are saved in the directory user lib kvd console fonts. The font you just set with set font is only temporary. When you restart the system, the font will revert to normal. If you want to change the console font permanently, you must make changes to the Grub file. So open the /etc/default/grub file. And in the grub command line, Linux, add vconsole.font equals ter dash 122 n. Save and exit. Update the grub.cfg file. The font is now permanently set. Change to super user. In this first method, you will use the key file to decrypt your LUKS encrypted volume. Secure boot and TPM does not need to be enabled for this. Create a directory /etc/crypt setup dash keys dot d. Create a key file with 4 kilobytes of random data. The key file has to be in volume.key format. Save the file in the directory /etc/crypt setup dash keys.d. Change file mode bits to 0400 for the key file. Add the created key to the encrypted device's available key slot. Use the command crypt setup LUKS add t. pbk df pbk df2 pb tdf force iterations to 500,000. /dev/vda2 and the key file. When prompted for a passphrase, type the same LUKS passphrase you provided before. You also need to include the key in the initram fs image as well. So create or open the file cryptodisk.conf in the directory /etc/drawcut.conf.d. And add the line install_items plus equals and the path to the key file. Please leave a space between the double quotes on either side. Save and exit. Now run the command drawcut with verbose and force. Reboot your system. Reboot the computer to ensure that everything is working properly. The LUKS passphrase should only be asked once before the Grub menu appears. You have now successfully logged into your system using the key file with the LUKS passphrase entered just once. In this method too, I will show you how to bypass the second LUKS passphrase prompt by using the TPM on your computer. For this method to work, you must have secure boot enabled and your computer must support TPM. Also note that I deleted the key file I created in the previous section and also deleted the cryptodisk.conf file and also excluded the key from the init ram fs image. As a result, you will be prompted for your LUKS passphrase twice, just as you were before. All right, first, change to super user. Make sure secure boot is enabled. As you can see, this system already has secure boot enabled. If it's disabled, you must enable secure boot by enabling it in the UEFI firmware. Next, check if your computer supports TPM. As you can see from the output, my system also supports TPM2 device, and the node path for my TPM2 device is /dev/tpm-rm0. Now, enroll your encrypted volume. The command to enroll is systemd-crypt enroll /dev/vda2 --tpm2 -device equals the TPM2 node path. That is /dev/tpm-rm0. Replace the device and node path according to your setup. When prompted for a passphrase, enter your LUKS passphrase. You must also include the TPM2 node path in the grub config file. So open the file /etc/default/grub and add the TPM2 device node path to the kernel command line parameter rd.lux.options. Save and exit. Update the grub.cfg file. Check to see if the TPM2 device node path has been added to the grub kernel parameter. Now you need to change the crypt tab file. Replace none and discard with -tpm2 device equals auto, comma, and discard. Save and exit. Update the grub.cfg file once more. Now run the command drawcut with verbose and force. Check that the encrypted volume has been enrolled with TPM. As you can see, TPM is mentioned in the second line, which is slot 1. reboot your system, the LUKS passphrase should only be asked once before the grub menu appears. In the next section, I will install Fedora's official desktop edition Fedora workstation, which comes with the GNOME 44 desktop environment. In this section, I'm going to show you how to install the graphical desktop environment. To find out what desktop environments are available to you, run this command. As you can see, under the heading Available Environment Groups, you have several desktop environment groups you can choose from, such as KDE Plasma Workspace, XFC Desktop, i3, and many more. You also have other groups of packages that you can add to the desktop environment or install the group independently. I will, however, install the GNOME 44 desktop environment that comes with Fedora's official desktop edition Fedora workstation. You may, however, use any other desktop environment of your choice. Fedora Workstation is now installed. Change to /var/lib directory. I will now create the remaining subvolumes. You need to create subvolumes for the directories, account service, and GDM. These subvolumes are only relevant if you install GNOME Desktop. They contain login user information, as well as GNOME display information. When you boot to a snapshot from the grub menu, the system freezes just before the GNOME login screen because the snapshots are read-only. These two directories must always be writable. By separating these two directories into subvolumes, you can ensure that they are always read-write and that the system does not freeze just before login. So first move the account service directory as account service -old. Create subvolume accounts service. Copy the entire contents of the old account service directory to the new account service directory. Restore SE Linux file contexts, if any. And now delete the account service -old directory. You no longer require it. Repeat these steps for the GDM directory as well. Rename the directory. Create subvolume GDM. Copy the contents. Restore SE Linux file contexts. And finally, delete the old GDM directory. Examine the directory permissions of the GDM directory. It should be 1770. Also, GDM should be the directory's owner. Now I will create a subvolume for the directory where the Firefox web browser saves files like bookmarks, passwords, and other user data. The directory is .mozilla, and it will be in your home directory. And then confirm your username with user ID 1000. And so typically the user ID for users created on Linux systems begins with 1000. Create a subvolume called .mozilla in your home directory. Replace the username with yours. Change the .mozilla directory's ownership to your own username. Restore SE Linux contexts on the directory. You must now add all 3 subvolumes that you just created to the fstab file. So open the file /etc/fstab. I will use the home subvolume as a template. Replace UUID and username with the UUID and username from your setup. Save and exit. Reload the /etc/fstab file to mount all file systems. As you can see from the output, all 3 subvolumes you just created have been successfully mounted. Check your subvolumes to ensure they have been listed. And your setup should now look somewhat like this. Enable the boot animation now that you've installed the desktop environment. I will set the spinner boot animation as the default. Now enable Red Hat Graphical Boot as well. Add the option RHGB I will also remove the console font option now that I've installed the GNOME desktop, and we'll be using the GNOME terminal instead. But if you want, you can keep it. And update the grub.cfg file. Now reboot your system. You will now be logged into the Fedora 38 workstation with the all-new GNOME 44 desktop interface. In this section, I will show you how to install and configure Snapper. Snapper is a command line program for file system snapshot management. With Snapper, you can create, delete, and compare snapshots and undo changes done between snapshots. So install Snapper and Python 3DNF plugin Snapper packages. After installing Snapper, you must create a Snapper configuration file for the subvolume for which you intend to create snapshots. First, create a configuration called root for the system root @/. Next, create the configuration called home for the home directory /home. Check that the Snapper configuration files have been created. Add your username to the Snapper's root and home configurations to set the ACL on the /.snapshots and /home/.snapshots directories. This allows regular user to use Snapper without requiring super user privileges. Open the fstab file and add the newly created snapshot subvolumes. Save and exit. Mount the newly created snapshots subvolumes. As you can see, the snapshots subvolumes have been successfully mounted. Check your subvolumes to ensure that both .snapshots subvolumes have been created. List your block devices. Your setup should look something like this. disable the indexing of the snapshots directories by update db utility. It is enabled by default and can cause significant slowdown and excessive memory usage if you have a large number of snapshots. List the snapshots for the system root volume. Also, list the snapshots for the home subvolume. At this stage, you do not have any snapshots. We will create some later. Snapper installation and configuration is now complete. In this section, I will show you how to install the Grub-Btrfs package. This enables you to boot directly to any snapshot from the Grub menu. By installing Grub-Btrfs, you add Fedora Linux snapshots link to the Grub menu, allowing you to test a snapshot in read-only mode before restoring it in read-write mode. So to install, first clone Grub-Btrfs repository from GitHub to your system. Change to Grub-Btrfs directory. Grub-Btrfs comes pre-configured to work with Arch and Gentoo Linux. But to make it work with Fedora, you must make a few changes to the Grub-Btrfs configuration file. So open the config file. Set the kernel parameter systemd volatile equals state. It makes the system boot with the root file system as read-only, and the var will be mounted as a writable temp FSRAM disk. Basically, the system will behave like a live Linux media without persistence. Next, uncheck the comment to set the location of the grub config file to grub2 directory. But unlike other distributions, Fedora keeps grub.cfg file in the /boot/grub2 directory. And then change the path for the grub2 make config command to /fbin/grub2 mk config. And uncheck the comment to set the binary, which checks the grub config file for syntax errors to grub2. Finally, save and exit config file. Now install Grub-Btrfs to your system. You'll see a no snapshots found warning, which is fine because you haven't created any snapshots yet. So regenerate grub config files so that the changes you just made are added to grub.cfg file. Finally, enable Grub-Btrfs service. The Grub-Btrfs is a daemon that watches the snapshot directory for you and updates the grub menu automatically every time a snapshot is created or deleted. Your Grub-Btrfs installation is now complete. You may now delete the cloned Grub-Btrfs directory. You don't need it anymore. In the next section, I will show you how to create a snapshot of the system root and set it as default so that the rollback of snapshots will become easy and error-free. Now that everything in Fedora has been installed and configured, it is time to take a snapshot of the system root and make that snapshot the new default system root. This significantly simplifies the management of snapshots and rollbacks. First, create a directory named 1 in the /.snapshots directory. Next, create an XML file called info.xml in the /.snapshots/1 directory. Go to the guide's web page, copy the script from sudo to eof, paste it into your terminal, and press the enter button. Now, create a read-write subvolume called snapshots of the system root in the /.snapshots/1 directory. List the Btrfs subvolumes and get the ID of the newly created /.snapshots/1/snapshot subvolume. Using this subvol ID, in my case 272, set the snapshot subvolume in the 1 directory as the default subvolume for the system root. Now reboot your system so that you can boot into the snapshot subvolume, which you set it as default for system root. After the reboot, confirm that the snapshot subvolume in the 1 directory is indeed the default subvolume for the system root. Now check the snapshots in Snapper. As you can see, snapshot subvolume in the 1 directory is also visible as snapshot number 1 in Snapper. The asterisk indicates that this snapshot is the default and is currently active. All right, the installation of Fedora Workstation 38 with full disk encryption, snapshot, and rollback support is now complete. You can now begin experimenting with your system without fear of destroying it and having to reinstall Fedora. I did some tests to make sure that everything is working well and that there are no problems. Please visit the web page where I detailed these tests so that you are sure you will not have to waste your valuable time reinstalling Fedora. I have also included a link to the web page within the description. And thank you for staying with me till the end. Please subscribe to my YouTube channel so that you are notified whenever I upload a new video about Linux. Take care, and until next video, bye-bye.